Okay, tonight, the title of our talk is Touring the Castles of Horny Heads in a Stream Near You. Dr. Emmanuel Frimpong is professor in the Department of Fish and Wildlife Conservation at Virginia Tech. He grew up in Ghana, where he received a BS degree in Natural Resources Management in 1997. In the US, he previously lived and studied at the University of Arkansas at Pine Bluff and Purdue University in West Lafayette, Indiana, before coming to Blacksburg in 2005. His research focuses on the ecology and conservation of stream fishes, with emphasis on ecological theories that model how anthropogenic alterations to that model to habitats affect species distributions. He is particularly invested in the study of chubs, focusing on their nesting and spawning habits and their mutualistic interactions with nest associate minnows. He has brought an entourage with him today, and so I will not introduce everyone, but we're happy that they're all here. Thank you and welcome.
I have my presentation.
Go ahead and introduce yourself, and then you can share.
Okay.
You can, go ahead.
Hi, everyone.
Hello.
And those of you on Zoom, sorry, I can't see all of you in person. So I'm Emmanuel Frimpong again. I am a fish ecologist. I know of the master naturalists. I've heard of many of the great things you do. In our building on campus at Tech, we have a huge chub that you guys made, and we interact with that chub a lot. And my and my research is all about chubs. So I've always looked for the opportunity to really come and talk to you guys and tell you how wonderful you are that you take care of the chubs so much. Just a few weeks ago, Bob contacted me about possibly doing one evening with you all. And it just happens that it is really a team that does the chub work, not just me. And a team that is so enthusiastic about everything chub conservation or educating folks about the importance of a species that is essentially ignored for all the great things it does. So I told the team, and the team said we'll be there. So I have 7 additional people here. And I have their names and their photos in the PowerPoint presentation. So I think we will not need to repeat introduction. When I put the PowerPoint presentation on, you know them by their looks. And everybody has a special distinct thing. Is I have tubercles. So you will be able to recognize them by the end of the day. What we are hoping to do today is to learn, to reflect, and to entertain, all centered around chub ecology. And so in a few minutes, we'll have the presentation on, and we mix the PowerPoint presentation in with the entertainment and with the art. So I don't want to waste too much time. I would rather get into the activity for the evening. We'll begin with Horny, one of our wonderful artists, doing a little bit of activity and reflection with the team. And then we'll open up the PowerPoint. And as part of the PowerPoint, you'll hear from almost everybody in this room. So we'll connect with you all that way.
Great. So I'd love for us to start by being in conversation with one person or 2 people next to you. And the question that we'll reflect on, and actually great, awesome. The question that we'll reflect on is, what is a meaningful memory that you have related to freshwater streams or rivers? So what is a meaningful memory that you have connected to freshwater streams or rivers. And I'd love for you to take this time, take a few minutes to engage back and forth with someone next to you. And I'll even time us. I would say a minute and a half per person. And I'll kind of send up a signal when I think you should switch. So you're sharing a story, a memory connected to a moment that you were in or near a freshwater stream or river. Does anyone have any questions? So find one person or two people next to you. I think our gang should participate in it as well. So go ahead and talk to one another. Did you catch the question?
Yeah, we already have a response.
Oh, great.
Camping by a stream, watching water striders, and making paint with ground rocks with my kids.
Amazing. Beautiful.
Yeah.
So we'll do,
You guys want me to pull up your PowerPoint as well?
we might be able to do that. Before we do that, we're going to do a kind of themes brainstorm. And I can facilitate it in the chat if that's useful, because I think I'll put the themes in the chat.
Okay,
So
whatever's
that folks
easiest
can
for you.
see it.
I don't mind doing it. And I don't mind taking this and, doing that as well.
Yeah.
I just,
I think it could go in the chat and that might be helpful for folks. Also, maybe I'll say hi. Hello.
Introduce yourself.
Hello, I'm Courtney.
You can do math.
Oh, okay, awesome. So awesome. We have a response from Sarah. And we have one from Beth and Fred as well. Wonderful. Please put your responses in the chat. So about 10 seconds and we'll switch to the next person. on Zoom can certainly unmute. And any others
We'll let him
from
speak.
our duos or trios? What about for you all? Natural wonder. Okay, yeah. And anything over. Who would say? Generational learning. Wow.
Walking in the creek, singing is the best thing you can do.
Love. So just a way to ground us in why freshwater streams matter, why chubs matter. We're connected to Bluehead Chubb's.
I just
Right?
unmuted,
They're so close to
but I don't
us.
know if they
They're
can
our
hear
neighbor.
her. Just the mic.
And so just wanting to open up a chance for us to connect with our stories and with one another before diving into our presentation. Thanks for allowing us into that time with one another. And I think we're ready for you to kick off the presentation. Yeah.
We're ready.
We're good. We're good. It just came unconnected for a second because I tried to move the computer so that they could see you, and I accidentally disconnected the projector, but we're good now. I'm gonna pull up his presentation and then we're gonna be good. That it? Oh, and then I need to do the share screen for the folks at home too. Oh, here it is. Yep. What? What just? Here we are. Okay. All right.
Wonderful. Thank you. So we're going to go through this as a team. And so I'm going to start off introducing the team. Of course, I've already told you, it's a team that makes the Chubbs hum in the New River Valley. It is a team that makes the Chubb shine. And the team of 8 in attendance today is maybe only half of the team that's actively working on Chubbs at Virginia Tech, and a very big NSF funded project. So those we have in attendance today, first is the Chubb Master, then Horny Sumanek, Eugene Marakis. Horny is a performing artist, if you didn't realize that yet, with the Center for Communicating Science at Virginia Tech. Eugene Marakis is a Chubb biologist. The biologists in general, but Chubb biologists like to have that attached to our name because we are a very select group of people. With the University of Richmond. Hiromi Okumura. Hiromi has been so busy taking photos. He's a visual artist with the School of Visual Arts at Virginia Tech. And then we have 4 graduate students in the Chubb lab on campus. All of them over here, Samantha Brooks, Emma Horton, Maddie Petts, and Thomas, who is so long you have to keep looking up to see his face. And this is a team that's going to help us interact, present some of what we know about Chubbs, what we are seeking to know, and everything that you want to ask us to tell you about Chubbs tonight. When somebody invites you and say, we want to know some of the Chubb work you do, it is a big, big ask, because there is so much you can tell people about chubs. And so I have been struggling over the last 6 weeks or so. What should I include in a presentation about chubs? And so what I have is a very compressed set of information about chubs, as you realized. But feel free to poke, ask for details wherever you want. If you have a curiosity about chubs that no one has attempted to explain, by all means, please ask questions. So close to home, near Blacksburg, this team is studying chubs. In Tom's Creek, in the North Fork of Roanoke, in Catawba Creek, and many other streams in the New River Basin in particular, we have done historical work for about 15 to 20 years now, studying various aspects of chub ecology. But more recent work is focused quite close to home. Why? Because we have plenty of chubs close to home. And charity begins at home. We need to understand chub ecology from our backyard, and then we can radiate it out. So usually from April to August, we'll be in the field. You might run into us if you like to visit the trail. Sometimes we bother you with questions. Otherwise, you may see a flag here and a flag there that sometimes folks wonder, what's all this about? It's all part of the plan to try to understand chub ecology a little better. We are looking to understand the natural history in a very holistic manner. And in addition, we want to connect with the public and tell folks about a lot that they don't know about such a wonderful species right in our backyard. So the NSF project that I'm the principal investigator of is a collaboration between Virginia Tech, the Fish and Wildlife Department, and the College of Engineering, and then the University of Richmond, where Eugene is our PI. In addition, we have our wonderful artists, the visual artists and the performing artists, brought together with us by the Center for Communicating Science, which own whole mission is to provide us with better tools to explain our science to the public so that the public can better connect to what we do. We admit as scientists that we are quite bad at explaining what's the significance of our work. Artists do it better. That's why we have a team of scientists and artists. So I want to tell you a little bit about the river chubs, the Nokomis species. Thank you. River chubs, as they are known, are a very select group of species in the largest fish family, freshwater fish family in North America, the Cyprinidae, now called the Leucistidae. This is about maybe 15% of all known fishes in North America belong to this family called the Leucistidae. And of these, about 150 species, only 7 are confirmed river chubs. And I have a list of them: Nokomis aspar, Nokomis bigatus, Nokomis ephysis. The one in our backyard is Nokomis leptocephalus, the bluehead chub. These are the chubs that build mounds. Then there are the creek chubs. The commonest one in our own area is creek chub, Semotylus atromaculatus. And there are 4 species in North America. And the one that actually builds very prominent mound is Semotylus corporaris, which is 4 fish. Add that to the Nokomis, and we have about 10 to 11 species that might build a mound. Another group of species that build mounds in the Leucistid family is tongue-tied minnow and cut-lips minnow. Those belong to the family Exoglossum. 2 species, they build mounds that are not really big, made with really, really small pea-sized gravel sometimes. Add that, and then you have 13 species. Then we have the stone rollers. They are the Compostoma species. And the different stone roller species, they do pits mostly, but you find them on mounds because they are also nest associates. And so as we're talking about nesters and nest associates, you see picture after picture of what you put up, you have stone rollers in there. So these, I did not assign any grade to them because they don't really build mound. They just like to be on mounds. But all together, you have about 13 species out of about 1,200 species in North America that build mounds. Then go all around the world, we have about 34,000 species of fish. The only place on earth where fish build nests with their mouths moving gravel is North America. And within North America, only these species that we are talking about tonight. So if you are one of about 13 in 34,000, you are very, very special. It is a very rare trait that we don't necessarily appreciate because we don't know how rare it is. It is rare and it's beautiful. All right. So I'm going to tell you a few things we know for sure about Chubbs, just as a conversation starter. And then this gang will file in one by one and tell us some things by going through the presentation. And Eugene will tell us some of his amazing experience of studying Chubbs by using video and photo documentation. And then when we are wrapping up, I'll hop up again over here because I love to moderate listening to questions and trying to answer questions. So what we know for sure is that Chubbs know what they are doing. Chubbs are not just out there messing around. They build mounds, they put them in very specific places in rivers because they know where is the best places to put your nest in order to get the best environment for eggs that will develop to fries and then ultimately become the next generation of Chubbs. And this is serious business because a fish's job, as I tell my fish ecology all the time, is to survive, to grow, and to reproduce. If a fish comes into the world and doesn't reproduce and dies, the fish is defeated. It did not leave its genes into the next generation. So come spring, every Chubb wants to participate in spawning and making sure that they are spawning in the best of conditions for their babies to survive and for them to leave offspring before they die. So one of the big themes of our current study is to better understand why Chubbs put their nest where they put them. Nest placement matter. Why is it in a pool tail and not in the riffle or in the middle of the pool? When you study it with engineering precision, you see that certain places dump more silt on the nest than others. Certain places provide more wash through of water through the nest than others. And as water washes through the nest is how oxygen is replenished. And so the fish knows how to choose even better than we do. And the nest is built and structured precisely to allow the water to not just climb over the nest, but to go through the nest, come out from behind, and then cycle and leave. If you take a walk and you check out a nest that has been there for a week or a few weeks, you will see a nest from the top looking like this. The front of it is clean, the back of it is silted. Even in a very clean river, when a nest sits there for a long time, this happens. Well, this means that certain parts of the nest are safer for eggs and larvae than other parts of the nest because silt smothers eggs. Silt prevents the flow through of water and prevents the replenishing of oxygen. So one of our themes in this study is to understand what is going on inside of the nest. Does the chub put its egg anywhere, or does it have specific places in the nest that it places its eggs? If the chub is putting its egg in very special places, and that is not where the nest associates get to put their eggs, you know there is a reason for that. The chub reserves the best real estate for its own offspring. And that is selfishness. Now, selfishness is a thing that rules the biological world. We all are selfish. Everything you see happening on the chub nest is motivated by the individual wanting to maximize his own ability to survive and leave offspring into the next generation. That means what the chub does might hurt another species, might hurt another individual. The same way the visitors to the nest may do something that may not be good for the chub, but is good for them. So it depends on whose perspective you are looking at a chub nest and all that goes on the nest. Everybody is looking out for themselves. And in the end, it's a beautiful interaction with a lot of motivation of selfishness that leads to a lot of the beautiful stories that we're going to share tonight. At the end of the day, what a chub is looking for is these clasps. These clasps make the future generation. A clasp and the spilling of eggs and milk. Some eggs sink into the nest, get fertilized. We have the future generation has started. The more clasps a male can make, the more likely you have more babies that will survive. So you have to build your nest the best way that will attract the best females, and that means you get more clasps. So we'll return to clasps somewhere along the line, I think. But from here on, these beautiful graduate students are going to tell us in a few more slides some things they know about chubs and fish conservation in general, that they might be able to tell it better than I can. So I think the next person here is Samantha.
Can everyone see me? Probably not. Someone entered the waiting room.
Yeah, sorry about that. I thought somebody else was.
So according to the American Fishery Society, over 50%. So according to the American Fishery Society, over 50% of the fish species that we have in North America are vulnerable. And unfortunately, many of us know more about vulnerable species internationally rather than in our streams and our local ecosystems. So as you can see in this graph here, we show that as time goes on, you find more vulnerable, threatened, endangered, extinct, and delisted species. And with the top two on the right-hand side, so the candy daughter and the Roanoke log perch, those are some that you may be most familiar with. These two are very endangered, and Emma, my lab mate, also studies the candy daughter.
We did that.
I need the touch of the Chub master.
Beautiful. Chub master. So like Sam was saying, a lot of times whenever any of us interact with community members and people from around here, and we show them pictures like the one behind me of a chub mound and all of its associates gathered around it, they ask where the pictures are taken. And when we tell them that it was taken in Tom's Creek 5 minutes down the road, rather than some reef off the coast of Belize or the Great Barrier Reef off Australia or some other really exotic place, they are amazed by that. And so I think that's the most powerful message around this ecosystem and surrounding everything we do, is that all of these beautiful creatures that are doing such wonderful things are right in your own backyard. So keep that in mind as we proceed forward.
Yeah, so all of these really cool fishes are in our own backyard, and that's really cool. But what's even cooler is that if we look at a map of the entire United States, the hotspot for fish biodiversity, specifically non-game fish like minnows that live on chub mounds, is that it's all concentrated in the southeastern United States, specifically places like Alabama. But we're actually in that bubble too. So we actually live in the spot to see these kinds of cool fishes. What's more, though, on the other hand, is that if you look at these maps, this also goes with, we have many more imperiled species of non-game fish as well. So this is a map created of imperiled fishes. You can see Southeast United States has the higher majorities of fish that are in danger of becoming extinct. And this is just more of a zoomed in map, and you can see that overall in Virginia, we have 10% of fishes. Tennessee has 15%. So a lot of these fish are in trouble. And it's not only that, it's a lot of fish that you don't typically think about, like bass and a lot of blue fish. It's these chubs and the minnows that rely on them that are in trouble.
And something that's really interesting about the chub mound is that it's actually, like Thomas said, this area is a hotspot. The chub mound is actually a hotspot within a hotspot. So like Emmanuel talked about earlier tonight, the chub mound attracts about a dozen other associate species in the New River watershed, although different chub varieties attract different species across North America. But in these chub mounds, here's a picture of one of them, and then each one of those letters represents one of the species that our chub, the Bluehead Chubb, affiliates with. And the chub is also an ecosystem engineer. Like Emmanuel was saying, they build these mounds, and that's something that's really uncommon in the natural world. So they really construct the stream ecosystem that all of these other species rely on. And so just to name a few, we have the mountain red-bellied dace, which is probably the one that if you were to go out, you would see. It's that yellow fish right at the bottom with the big red belly. And some of the stone rollers and the shiners are in the back. Yeah. Sam, take it away.
So how they create these mounds, as we've been talking about. So the Bluehead Chubb makes these mounds, but the Bluehead Chubb makes these mounds out of pebbles and gravel. They collect pebbles from the stream, and they move them to about 10 feet away, or approximately 10 feet away from where they collected the mounds. But they do this ranging from 20,000 to 100,000 times, each pebble individually, one by one, moving this. It's a very tiresome process for them. But it's awesome because these mounds are not only used by themselves, but also used by other nest associates, which, as you saw in the previous photos, and then also these, you see the mountain red-bellied daces, the stone rollers, and all of these fish use these mounds for reproduction. And Emmanuel had a picture in one of his slides earlier where the back side of the nest was silted while the front side of the nest was clean. They make this depression in the front of their mounds, which is the main site for reproduction and spawning, which is where not only the Bluehead Chubb, but many of the nest associates also use for their laying of the eggs. And you can see in these two photos here, we have cooperating and non-cooperating. So eventually, or sometimes, multiple Bluehead Chubbs or Bluehead Chubb males, as we consider the hosts, there's one host of the nest, but these sometimes multiple Bluehead Chubbs end up going to one specific mound. And sometimes there's some competition between these Bluehead Chubbs of who is the host and who remains the host of these mounds. So you can see here of where these three Bluehead Chubbs are cooperating, where they're sticking to their own job, their own space, while this side, they're not cooperating, where they're fighting for dominance. You see the tubercles on the top of their head, which is what they use to fight against other bluehead chubs.
It's male and female.
These are male bluehead chubs.
Both of them are male. When they pair like that, they are about to fight. They come close and check who is bigger. And usually when one is smaller, they will run away. But if they are about the same size, fights usually follow.
But the male and the female both protect the nest.
Males only.
The females just swim by and check out the nest and determine if they want to spawn on it. So they're actually, yeah, they're not actually there the whole time with the male.
You check if your nest is beautiful or not. Your nest is sturdy where they go to another.
And what's really awesome about these founds is that you see such vivid colors that are not normally what people in this area would expect to see in our local streams. Normally, one would think about bright, colorful fish in coral reef ecosystems, things that all of us are used to seeing with like conservation and management tactics with those of international, like, or for nonprofits and such. But it's awesome because we see these beautiful, vivid colored fish in our streams that are in our backyard. So it's this really awesome, like these bluehead chubs make these engineering marvels per se, that we can see that are just right out in our backyards, which is really fascinating.
So to close off, where did my, huh? Oh, sorry.
She's getting too excited.
After you.
Yeah, so there's a common saying, I don't know if you guys have heard it. It's if they build it, they will come. So as these chubs are constructing these pristine habitats for reproduction, it attracts in the process all of these nest associates, the fish that we've been talking about this whole time. Mountain red belly dace and rosy side dace and central stone rollers. You can all see them in this photo. But think about it for a second. Why would a bluehead chub invite all of these fish on its home? If you guys built an apartment by hand, would you want to wake up to a ton of squatters? Probably not. So that's part of what we are trying to figure out in our lab. That's what Emmanuel was talking about at first. We have, for one thing, that the bluehead chub itself could probably protect itself from predators by keeping itself in the center of the nest, as you can see here in this photo. It essentially creates a little fish shield around it. Protects itself. And also, if you look, okay. Also, if you look within the nest, you may be able to see, we may be able to determine if bluehead chubs keep their eggs in sort of a bubble in the most pristine area of the nest, while all the other fish are kept out to the sidelines. So it may be a way of protecting itself.
now it's my slide. Let me try to move this, or maybe I can't. Here we go.
Yeah, if you click on more, you can video 5 loading now.
Oh. There we go. Perfect. So to close out this portion of the presentation, Eugene's going to talk in a minute. We have a quote here from R. Jenkins: "The future ecology of a stream begins on a chub nest," which I think you can see how this applies based on everything that we've said today. But what's interesting is that many times we don't even know the extent of what's happening on the chub nest or how the stream ecology begins on the chub nest. And that is where art comes into play, both through visual art and also through videography. And that's why we've incorporated our lovely artists here today. Maybe. No. I'm very bad at this. There we go.
So
Again, I'm Eugene Maracas, University of Richmond. I'm a research scientist there, and professor. And I took a photograph, well, actually, one of my colleagues took a photograph in 1989. I've been doing this since 1987, so about 34 years. And I was so impressed with this photograph because it really captured the essence of us trying to capture the fishes and their behaviors. And so a photograph is nice, but when you can use the emotional side of our brain and our being, then you can begin to express things that science can't express. And so I began to paint paintings of fishes and us in the field. And the reason is this: nobody reads my scientific papers. I mean, I might have 80 papers, peer reviewed, but the general public doesn't read them. But what they do like is art, music, poetry, sculpture. And we know from neuroscience that when you can help the emotional side of the brain see something new, then the emotional side is going to say, wait a minute, this is really important, and I'm going to remember it. And neuroscience tells us that people that have experiences with science information communicated through the arts are more likely to remember it. They find it exciting, and as a result, it'll have a meaningful impact on them. In this one paper I found said that we need the arts because science cannot communicate to the hearts of people like the arts can. And once you can reach people's hearts, then you can begin to change their behaviors, show them how to change their behaviors. Anyway, so yeah, a few paintings here and there, and let's see, forward. So actually, this is one of my former graduate students, Mark Sabay. He got his PhD, now he's at the Philadelphia Academy of Natural Sciences of Drexel University. It used to be Philadelphia, but they changed it. Anyway, but Mark, in his thesis, worked on what are the interactions between a male and a female that leads to a successful spawn. And what we did was to review videotape over and over again. And what we thought we saw in the field, because when we were in the field videotaping, we also made notes, okay? And we got back to the laboratory, looked at our notes, looked at the video playing at just regular speed, and then we played it. They said, well, let's look at it in slow motion. So we slowed it down and said, yeah, that's what's going on. And then we began to play it frame by frame. And it flipped many of the things that we thought we saw, and actually historically what people wrote that they saw, were actually totally opposite. And so here's an example. So here's a nest, and Emmanuel talked about the spawning clasp of the male. What we were able to do was identify 6 sequential interactions between a male and a female. And the male, this is called the interim, when the male is hovering over the pit where he wants to spawn. He might fan it with his anal fin. He might pick a pebble or 2 out of it, trying to shape it so it can accommodate his size and the female size as well. Well, the female then begins to make an approach. Then the 2 align. And this alignment is both male and female trying to get next to each other. Excuse me. Then the female here begins to make a short little run. She moves forward a little bit. And then as she does, the male moves up too. And then what she does is to throw herself vertically into the water column, and then the male clasps. Okay? But when you look at the video and you see it in nature, and you see it in a video in normal speed, it looks like the male is throwing her up. No. She's actually retroflexion. She's throwing herself up, and then he clasps her. So, you know, they take a picture's worth 1,000 words. Well, to me, video is worth billions because you can play it frame by frame and see things that you have never seen before. And so we kind of flipped some of the thinking about some of the behaviors that have been written about previously that no, it looks that way, but when you play it frame by frame, no, it's not. Anyway, we're enjoying ourselves. We're having a great time. And then this one, look at that, art, right? My wife was in the garden. I was in our sunroom, and she said, honey, come out here for a second. I said, what is it? She said, I got to show you something. So she showed me these 2 eggplants, and on the vine, and they were clasped, like the male-female clasp of the Bluehead Chubb. And so I sent it to Emmanuel, and then he sent it to the grad students. And anyway, so you got to have a lot of fun with things like this. And here's a cute little girl right here. There was at an event a couple months ago, and she drew a picture. She was so proud, bless her heart. Anyway, so that's it for me. I think that's.
What Eugene did not say is that the graduate students did not recognize the falling class. My most disappointing summer of all. This little girl drew the chop that you all made when we did the program at the Heritage Park, Science on Tap, in July. She visited with her parents and basically rendered her version of that chop. And it's still the winning rendition of chop by a 4 or 5 year old that I have ever seen. So for a long time, she's going to reign supreme. And with that, I think the floor is open for any kind of questions, probing, interaction that you all have.
What is the density of the chubbs? Like, how many mounds would you find in the spring where they're dead?
That is, it varies, but in our local streams, for every 100 meters, about 300 feet, you might see about 20 to 30 nests over the season. They don't all happen at once. Over about 6 weeks to 2 months, they come and go. Sometimes the storm just buries them or washes part of them and they repair them. So not the standing number of nests, but the distinct nests that are started that get to a decent size, about 30 nests per 300 feet.
How long from the time, what is maturity in a bluehead? Like, what time frame is it for, like, can I ask you a question? Can you answer the questions closer to the mic? So people
I'm
can
sorry,
hear?
I was trying
Sure.
to type
And
as well.
Also, if you could repeat the questions because they can't hear the questions from home.
Sure.
So, okay.
So we had a wonderful question about what the density is of Bluehead Chubb nests in a creek. And I was giving an example of a local stream. I think it varies, but in some of our local streams like Tom's Creek, for about 300 feet, you see about 30 nests over the season, which is about 2 months, 6 weeks to 2 months. But you don't see all the 30 nests at once. You see maybe 5 or 6 pop up early in May, mid-May. Then Memorial Day is where most of the nests are built. If Memorial Day is a beautiful day, you want to see chub nests, go out. And maybe 15 of them will be there at the same time. Then the storms will come and wash some away, and then they will return and fix some and put new nests in and back and forth by the end of the season, which is late July, you would have about 30 nests built. And the second question was the maturity.
Yeah, how long does it take? for maturity to occur?
So most of these minnows actually mature in their second summer after they are born. So the female chub, most likely by the late summer of their first full year of living, they are starting to be mature. The males, if they spawn in their first summer, they are probably going to spawn very late in the season because they are not big enough. And they need their big mouth and intimidating size to gain access to the best places in the stream to make nests. So they probably start spawning in their second year. But they do apprentice sometimes. They check out nests and they get head-butted away from those nests, but I think they are looking to see how it's done in their first year, and then in the second year, they will.
How long, what is their lifespan?
A male chub may live about 4 years. The females may be less, maybe 2 or 3 years. What do you think, Eugene? Yes. Yes. A prime chub location. So they like the deepest part of the cross section of the stream. If you're looking at a stream, you know, a stream meanders and goes through its own path in the broad stream that you see over there. There is a place where there will be water even when there is a trickle. That's usually where they want their nest, because in the event that water is so low that other parts of the stream don't have water, they hope that their nest still has water. And they also put the nest usually at the tail of pools where the speed of the water is fast, but it's not too fast to erode the nest.
But not if the nest is even a little waterfall or ripple.
Yeah, that will be, a waterfall will be able to destroy a nest. You know, the strength of the force of the water will scatter the gravel. And, you know, they are limited by how heavy of a gravel they can carry. So that has to play into how fast of a water, even though they want water flowing, how fast of a water they can choose to put their nest in. Also, they themselves have to withstand a lot of force of water when they are spawning. It takes a lot of energy to stay on the nest without fighting water all the time. So they have to look for a place where there is flow, but not too fast to have to spend all your energy staying afloat. And sometimes because of that, they may actually seek places with some shelter closer to the bank or a big boulder or something like that. So they can rest by hanging around the nest, but not necessarily in the flow.
I know we have some more questions before.
Yes, I will.
So these are just a little questionnaire about freshwater streams. And if you could fill these out for me, and I don't know if you can do it tonight. So you can have it. And it would be great. It's I've got about 60 other people that are on this, and I need about 60 or 70. Thank you.
Multiple males on the nest, so you're like one dominant male and then others working together, or how does that work?
Yes, so most nests would begin with one male. So the question was, the pictures we are showing some nests with multiple males. And the question is whether there is a dominant male or how does it work? Most nests will begin with one male, but over time, that nest will be visited by multiple males. And some nests will actually grow in place to very large nests where many males can have their own stations on the nest and be able to coexist because there is enough space for everyone. But in general, every nest begins with one male choosing the spot and beginning the nest. And a lot of the fighting that you see happens at the beginning, where one male thinks this is the best spot, another male thinks that the next 1 foot away is the best spot. They do a lot of combat and antagonistic behavior at that time because everybody wants to be the dominant male. Once spots have been chosen and the nest begins to grow, the nest is spreading, and the chub actually needs a lot of visitors in order for him to be safe from all the onlookers who are looking to prey on the nest. So, turtles, snakes, herons, in the night, raccoons, etc. All these animals are predators on chub nests. It is not safe for the chub to be alone on the nest. He actually wants others around. So that encourages the visiting of the nest by other males, by nest associates, by a ton of fish, so that the chub feels very safe in that mix. And so eventually, a male chub accommodates other males, because the more males you have, the bigger the nest grows, and the more nest associates converge on the spot. And the safer everyone is, the safety in numbers.
And what are they eating? Are they filtering leaf matter that's coming down the creek, or what are they?
That's a wonderful question. The question is, what are they eating when they are spawning? So unlike salmonids, that normally the salmon, the migrating species in particular, they will feed and store all the energy they need to go through the entire reproductive season. And that's why they have the adipose fin over here, which is actually the last backpack they have with lunch, is that little spot fin over here is filled with energy. These chubs have to feed as they are spawning, and they approach it in two ways. One is the spawning is not a one-time, one bout, and it's done. Each male will probably have about 4 nests through the season, where they take a break and they feed and they replenish and they start another nest. Even if the weather is okay and everything, a nest that goes through its full cycle eventually will stop, and then eggs will be incubated, and the chub will use that time to feed and leave the nest undisturbed, so that the eggs are not suspended by all the frenzy on it. But another way that we think they acquire energy, and that's actually Maddie's thesis, is the chub is often seen munching on things on the nest almost all the time. And we think they eat eggs right from the nest. What we don't know is whose egg they are eating. If I was the chub, I would eat the eggs of the nest associates. And there is a lot of nest associate eggs to go around. By the end of the season, one nest may have 10,000 eggs. 90% of it will be eggs from the nest associates. So there's a lot more eggs from those that don't build the nest than those who build the nest. Fish have very, very keen sense of smell. They can distinguish their own eggs from other species' eggs. Some species, like some fishes, have been shown to do that. They selectively eat the eggs of other individuals, even of the same species. So we think they do eat eggs off of the nest. We know for sure that nest associates eat eggs off of the nest. If the nest associates eat eggs off of the nest, why wouldn't the chub? So Bamadi is, in the next year or two, is going to provide a definitive answer by using genetics and going into the stomachs of chubs and try to figure out what they be eating. Yes.
What is the symbiotic relationship among the nest associates?
So we characterize nest association as a symbiotic mutualistic relationship, because for one thing, the chub benefits from the nest associates being there, both by protecting itself from predators, because it's embedded in this big mass of many different species and individuals which are surrounding it, and it sits in the middle. But it is not a complete loss for these nest associates, because if you look around and the stream is all silted and there is no place to spawn, the chub nest is a wonderful clean gravel raised above the substrate where you can spawn. So even for just this trade-off, they trade off the risk of being on a nest where they could be prey to a snapping turtle. They trade that risk for a beautiful spawning environment. So that's just one. The eggs that are put on the nest are also preyed on by all sorts of creatures. Crayfish. You have videos where they sit on the nest and they because they have the apparatus to actually move gravel, they take gravel with their claws, put it away, and open up the nest and eat eggs. That's just only one species that we know prey on eggs. All kinds of insects, darters, other fishes that are small, and scorpions and so forth, they all know where eggs are. And so if you have all these different predators trying to, and to some extent succeeding in feeding on the eggs on the nest, then you want to dilute the risk of your own eggs being eaten. So the chub makes sure that there is as much attendance by anyone who wants to put their eggs on there, so that the chance of its own eggs being eaten by all these predators is much lower. And of course, if I build a free nest and I said, come, and you come, then you should pay something. You should pay the price with some of your babies. Yeah.
We have a couple questions in the chat. Maybe I can read them.
Yes.
So we want to know, how does excess stormwater affect the nests?
So Thomas is actually investigating the impact of urbanization and flashy flows on nest survival and all that. We think that stormwater in general is a natural thing, that some nests will be washed and they'll be washed away and they'll be rebuilt and all that. But with urbanization and with the creation of channelized streams and so forth that allows water to flow too fast, too high, nest destruction is a more frequent thing. The impact on the nests can go from flattening the nest to completely obliterating the nest, or dumping so much silt on the nest in one storm that it is too much for the chub to try to unbury the nest. You see them trying feebly sometimes to dig up a big nest that just got buried after a storm, and they can succeed in building a tiny bit of nest from a very large nest that got buried because it's too much work. I mean, it's impressive to begin with that this 7-inch long fish can build a nest that big. But if it gets destroyed, where is the energy to rebuild the entire thing again? So generally, unpredictable storm flows and very, very high water is a problem for the chub. Somebody asked where we can get a cool hat. You have to talk to me in private. It's very rare hats to find. One thing about chubs is if there is a place they are not at, it's probably because they can't survive there, at least in their native range. Because the Bluehead Chubb in particular, they are very resilient, and they go all the way up to the smallest streams you can find. And of course, as you go to larger streams, as you go downstream, as the stream becomes bigger, chubs are not disappearing. It's just that different species of chubs replace the Bluehead Chubb, because the Bluehead Chubb is not a particularly large river chub. So if urbanization or some other factor becomes so extreme that it makes it impossible for chubs to survive there, then you don't find them there. But it's not likely that you can introduce them and make them survive, because there is a reason that they are not there in the first place. So it will take a much broader restoration effort to reduce the factors that are eliminating them from certain streams. And of course, temperature can be a problem too. If you have a very cold water, chubs are not particularly cold water fish.
We expect that in a lot of these small creeks that we have, there could be chub, right?
Oh, yes.
In most.
When you say small creek, how small are you thinking?
Falling range. Christians where it's about as wide as half.
Oh, yes. This size, half of this room, that's way more space for chubs then. Poverty Creek is a very small tributary of Tom's Creek. It's big in some places. In the summer, the only two species in some of those pools when the flow is so low is Bluehead Chubb and mountain red-bellied dace. They go as far to the smallest tributaries as they can find.
I think I missed one of the most important things, but why is it built about? The eggs, are they inside the mound? Are they on top of the mound? Are they filtering through the pebbles? What is the purpose of?
So the question is, why do they build the mounds, and where are the eggs? Are they on top of the nest? Are they inside? They build the mounds because they have to hide the eggs. So one of the richest food sources you can find in a creek is eggs. So every fish tries to put its eggs somewhere where it's not likely to be eaten. Maybe they hide it under a rock, a slab. Maybe they attach it to the underside of a leaf. Maybe they put it in the sand and just bury it in the sand. A few fish in large rivers will scatter the eggs in the open water where it is so scattered that if you want to eat them, you have to do a lot of movement to eat one egg here and one egg there. So that's also a good strategy. It's just too difficult to find all the eggs and eat them. So there are all these different ways that fish try to keep their eggs from being easy to access and eat them. The chub's goal is to hide them. So in fact, the primary goal, the primary mode of parental care in these chubs is brood hiding. And so the chubs have chosen to hide theirs by putting them on the mound, then piling gravel over it. So they start with a small mound, they dig these little pits, they spawn in it, then they cover it. And then as long as the chub is active on the nest, whether another chub comes in to spawn, the same chub spawns, or nest associate spawns, if eggs are exposed, the chub will keep covering them. So that's its work for the whole time. So you can tell how busy a nest has been with spawning just by its size. A nest doesn't just grow. It grows because it's being spawned on and it's being covered. So the eggs are everywhere inside of the nest, but everywhere is relative. The back of the nest is used much less, and the nest grows usually in the upstream direction because the back gets silted from the photo that I showed. So especially the chub's egg is rare to find in the back. But the nest associates, some of them are just passing by and they're opportunistic and they spill eggs on the nest everywhere and they go. It still gets covered, but it may not be in the best place. The chub does not put its egg in the back. It's up front, upstream, where the water first hits the eggs and washes them and supplies oxygen constantly. Well, before we wrap up, I would like to say this is a conversation that can go on for a long time. We would love to visit you as often as you would like. In fact, we told Bob we would like to take you all on the trail, Deerfield, sometime. We were hoping for the fall, but it's starting to get cold already. So proposals have been made that we should do them in the spring. But we can do walks during the spring in small groups if necessary and talk about Chubbs, where Chubbs live. So just if you don't have the chance to ask questions, we are not done with you all. Thank you very much.
Oh, the Zoom folks. Okay. Well, thank you, Zoom folks. I hope you could hear everything. Was it okay, I hope? Good, good, good. We're now going to do the interactive part that's hard to show you, and the video clips will be attached to the recording.
Thank you.